Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of equations for parallel lines. This is standard A.2E in the great state of Texas, and we are using item number 19 of the 2021 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we need to find an equation in standard form. So we have a little bit of work to do. It's not going to be in point slope. It passes through this line and is parallel to this equation. So what does that word parallel mean? Because it's not going to be given to us as a definition on our reference material. So parallel lines are important when we're looking at graphing them. So parallel lines have identical slopes. And that's the key thing that we need to remember. Identical slopes, equal slopes, equivalent slopes, the same slopes. However you want to say that word identical, equivalent, the same. So we need to find the slope of this line, because whatever the slope of this line is going to be the same as our new line. Now that is not in slope-intercept form, so we have a little bit of work. So let's take our standard form here. We want to get it into slope-intercept form. So remember, our goal is going to make it look like y equals mx plus b, because if we do that, that's our slope right there, that m. So let's isolate the y. So we're going to subtract 8x from both sides. Right, so we're going to get 3y equals negative 8x plus 15. And then I just need to divide everything by 3. Gets rid of that, so that's kind of distribute this out. That's going to be negative 8/3 x plus 15 divided by 3 is 5. All right, so that's this right here. This is our original. So here's my slope, negative 8/3. Right? So we're going to keep that in mind. Now, that is our line that we need to find a parallel for that goes through this point right here. So we've got options. One option is let's just plug in the x and the y. Right? If we plug in the x and the y, that's going to give us our new y-intercept. Because remember, parallel lines have identical slopes. They don't have the same y-intercept. So I need to look for my new line with y equals mx plus b. But remember, I just found my slope, a/3 x plus b. So I'm going to plug in this negative 1 as my y. I'm going to plug in my 6 as my x, and then all that's left is the b. Now obviously I need to simplify this, so negative 1 equals, and that's going to be 2, negative 16 plus b. So if I add 16 to both sides, right, that's going to give me 15. b equals 15. So put this 15 back up here, and what we get is y equals negative 8/3 x plus 15. These are two parallel lines. This is the one I'm looking for. Now, none of my answers look like this because I have to now put it back in standard form, right? So how do we do that? Well, let's get our 8/3 x back over here. Right, so I'm going to end up writing that up here. So I've got 8/3 x plus y equals 15. We don't really like any of our coefficients to have a fraction, so I'm just going to multiply everything by 3, distribute that out. That's going to give me 8x plus 3y equals 45. All right, so now we've done all of that. We say our answer there as C. So the other option is, rather than plugging in, we could have used the point slope form. Y minus y1 equals m times x minus x1 with our new slope, and plugging in the x and y. That also would have given it to us in slope-intercept. We still would have needed to get it back into our standard form. And our answer here is C.